An important consequence is that iterators simplify the interface of your aggregate structure. The traversal code is separated out in separate classes. This follows the single responsibility principle. Seeing we are working on interfaces and not implementations, the open-closed principle applies as well. You can implement new types of aggregate objects, and iterators can exist next to each other at the same time on the same collection. In other words, you can be traversing a collection with an alphabetical iterator at the same time as you're traversing it in the order items were added. As the iterators store their own position, they won't interfere with each other. A disadvantage is that using this pattern can be a bit of overkill when you only use simple traversals and collections. It's mostly useful for more complex situations. Let's have a look at the related patterns. The iterator is related to the composite pattern. This is a recursive structure, and iterators are often used to traverse those. It can also be used in conjunction with a memento. In that case, the memento can be used to store the state of the iterator and potentially roll it back. Lastly, the visitor pattern can be used in combination with the iterator. You could use an iterator to traverse a potentially complex data structure and use the visitor to apply some logic to the items in that structure. And with that, it's time for the module summary. We learned about the iterator pattern in this module. It's very common, but mostly as far as using it is concerned, not as far as implementing it goes. Its intent is to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. In regards to implementation, it's quite easy to build all parts of the iterator pattern except the actual concrete iterator itself. Remember that for that, you can leverage existing framework code. You don't need to start from scratch here. Up next is the visitor pattern from the related patterns list.